We have a fascinating future ahead of us wherein AI agents collaborate with us and each other to solve humanity's biggest challenges and improve quality of life for all. But a major hurdle toward this Elysian future is being able to trust agents. How are we going to do that? Welcome to the Super Data Science Podcast. I'm your host, John Krohn. I'm joined today by Dr. Vijoy Pandey, a brilliantly thoughtful and well-spoken engineering researcher who heads OutShift, a tech incubator inside of Cisco. In this episode, Dr. Pandey reveals an open-source agentic AI project that resolves the question of trusting agents and so much more. Enjoy this one. This episode of Super Data Science is made possible by Anthropic, Dell, Intel, Fabi, and Gurobi. Vijoy, welcome to the Super Data Science Podcast. It's a treat to have you on the show. How are you doing? Where are you calling in from?
I'm doing great. I'm calling in from San Jose, California. It's sunny outside and it's pleasant. And it's
Nice.
a pleasure to be here.
The heart of Silicon Valley. That's fantastic. Yes. So Vijoy, you are Senior Vice President of something called OutShift by Cisco. Tell us about OutShift to give us some kind of, I think every listener is going to be aware of the Cisco brand, but maybe not the OutShift brand.
Yeah, so OutShift is an internal incubator within Cisco. So our entire mission is to incubate new products all the way from ideation to customer traction. So we're structured as startups with engineering, product, marketing, customer support, sales all rolled into one. And we look at problem statements that are adjacent to Cisco's core businesses. So if you think about Cisco, like you said, we are familiar with a networking giant. There's security, there's observability, especially after the Splunk acquisition, and then there's collaboration with WebEx and so on. And so we look at personas and problem spaces that are adjacent to those four pillars, and that's where we incubate.
Fantastic. That was a great intro. I actually learned more about OutShift than I ever knew before. And within OutShift, there's a particular initiative called AGNTCY that I think will be of interest to our listeners. And so this has a funny spelling. It's AGNTCY.
That is excellent. You get 100 out of 100.
I did that without looking at any resource. That was from memory. AGNTCY. And so tell us about AGNTCY from OutShift by Cisco.
Yeah, I think before we even get into agency, the way this thing all came about was we were looking at a problem statement almost about 2 years ago, where we said, agents are here. They're going to help us solve for all kinds of human work. And so, how can we build a platform where agents and humans can collaborate with each other and solve for a business outcome, a social outcome, a physical outcome, or a services outcome, or whatever? And so that platform was missing. And we strongly believed, I mean, if you think about Cisco, we were one of the few companies that were behind the original internet and the way it transformed. And it was open and interoperable. And that's why it's successful. And so, with this collaboration platform for agents and humans, we thought it should be like the original internet. And so, we came up with this thesis called the Internet of Agents. And the openness comes from open source these days. Standards, yes, but open source are the new standards. And so we said, what better way to influence standard specifications and how it's deployed and consumed than by taking Internet of Agents and making it open sourced? And that's what agency is.
Really cool. And before we started recording, you started to tell me about how you're excited for a future that will involve collaboration between teams of agents and humans. In fact, I guess you might not even think of it as teams of agents. It's just this multi-agent future where agents are available and collaborating with each other or with us on all manner of tasks. Vijoy, tell us about your vision for the future that's coming.
Yes, I'm a strong believer that in the future, you'll have societies that are built of humans and agents. And these societies will help us solve for the biggest problems that face us. That is the understanding of the self, the understanding of the universe. So, personally and selfishly, I'm looking for better medication, I'm looking for better materials. I'm looking to figure out how did the universe form? Where are we headed? So that's where we are going towards. And us humans alone are not going to be sufficient in that journey. And so, to solve for those bigger problems, we need these societies and teams that are multi agent human societies. And these agents are not the narrow term that we use today, which is if you think about agents today, you think about agents in business software. I mean, how boring. You think about agents in services and agents that write code for you. I mean, it's great, but it's like how myopic and how boring. So you need to think about agents that are helping you discover materials and drugs and so on, scientific discovery. You think about agents, probably better than what Mark Zuckerberg talk about, but agents that help you socialize and interact with each other. Agents that will help you, of course, solve for business and consumer needs and services, but most importantly, agents that are also embedded in physical form, whether you call it physical AI or embodied AI, and they help us accelerate all human work, even in the physical domain. I mean, the first thing I want agents to do is do my dishes. I don't want my agents to paint a picture for me because that's what I enjoy doing. I want to play my guitars. I don't want to spend time doing dish loading or washing my clothes. So I think that entire spectrum of discovery, of work, physical work, of business work, social interaction, all will be solved through and accelerated through these multi agent human societies. And that's where we all technologists need to aspire towards.
For people not watching the video version of this podcast, there are multiple guitars behind Vijoy. Vijoy, are some of the things in frames hanging on the wall, or any of those your photos or pieces of art?
No, but I do dabble in photography as well. But
Yeah.
what you see there are LPs and vinyl from the 60s.
Oh,
And
oh.
I'm a big I spend money in audio, I spend money in photography, I spend money in a bunch of things that I want to continue spending on, and I want to
Mm,
develop agents that actually help me do the monotonous and the
yeah.
boring and the toil.
So you can have an agent do your podcast interview, and you can be learning a new guitar solo.
I'll be in the background riffing
Yeah, yeah,
and drinking some wine.
exactly. Nice. I like that. That's something, that particular idea is something, one of my favorite guests that we've ever had on the show is a woman named Natalie Mombayo, and she specializes in this idea of digital twins, where you could theoretically have, I mean, not theoretically, she works at bringing them to life today with the technology that we have today, so that you could, in a Slack channel or even in a video format, have a digital version of yourself be able to answer common questions, be able to maybe do a podcast interview for you. But so that's a really exciting vision for the future.
Can I interrupt you right there because
Absolutely.
one of the things that we've been looking at is, so you said digital twins, and digital twins can be twins of humans, they can be twins of systems, they can be twins of the world that we see around us. So physical twins of digital systems and humans. And this is an area of research. This is an area of how to solve for this agentic future that we just talked about that actually excites us the most. Because one thing that we've realized is that we are at a point in time where we have a set of tools that we were familiar with in the computing space that were deterministic in nature. And now we have a set of tools that are coming up that are probabilistic in nature. And this is using either traditional ML or agentic AI and generative AI and so forth. So you have deterministic tools, you have probabilistic tools, and you can pick and choose, you can blend the two worlds, and that's how you solve for problems. The issue is that the craze that is behind LLMs and agentic AI and generative AI is forcing people to just think about the probabilistic tools. And in some ways is ignoring the plethora of deterministic tools that really work well in a lot of situations. So the one area of research, and it's not new, but it's coming. You're seeing a resurgence behind that is neurosymbolic AI. And the whole notion behind that is just neural networks or the neuro part of it is not enough. Just the symbolic or deterministic or knowledge graph or ontologies, whatever you might want to call it, the deterministic part of it is not enough. But the combination thereof is where the magic happens. And so you talked about digital twins, and that triggers this thought where we actually came up with a whole bunch of use cases. One particular one in the network configuration pipeline and validation pipeline that we built uses a digital twin of the network and then throws in a bunch of agents which are agentic, like generative AI and probabilistic in nature. And the combination of the two gives us speed and accuracy at the same time.
That does sound very cool. Does when you say symbols, it also makes me potentially think of symbolic learning, which could potentially vastly accelerate learning for machines and vastly reduce the amount of data that are required in order for machines to learn. And so this would be a bit more like how children learn, where they don't need a million examples of cat versus dog images in order to be able to label the images correctly, like a machine does. They're just able to see, one or two examples, and you correct them a couple of times. And so does that relate into this conversation?
Yes. So I think that is where the neurosymbolic movement started from. But I think you can expand that out by saying you can combine the deterministic worlds and the probabilistic worlds together. And then the outcomes that you get will have better accuracy and of course the speed that you expect to get. Also, it'll allow you to explore things in a better way than simple symbolic or deterministic systems as well.
That is all fascinating, Vijoy, but I want to get back to the idea of these multi-agent human collaborative societies a little bit. You mentioned how it won't just be boring business processes, on the internet and the cloud, on people's machines that are being handled. It sounds to me there like you might also be talking about real world embodiments of agents like robots. Is that correct?
That is correct. So the way we think about the way agents are going to come together and collaborate, and I'll give you one example, which is one of my favorite examples that actually came in through a pharma company. And they were talking about this whole motion from wet labs to dry labs or in silico discovery of drugs. And the way he was describing the process, this person was they're using LLMs to first figure out a plan and the goal for what drugs they want to discover. So you start with an LLM, you go through some reasoning, some plan discovery planning, and you come up with a plan. And so that's the LLM front end, so to speak, to this entire process. From there, you would go to a scientific foundation model. So something like a protein folding model, where you an AlphaFold, where you explore all the possible scenarios for protein combination, and that's the language that foundation model is speaking. And it's a pure exploration. And so based on that exploration, you tweak it, you prune it, you figure out what of those makes sense to then go towards a wet lab. And so the wet lab is looking at robotics, embodied AI, taking those explorations and actually trying it out in real life, in the physical world. And from there, you would get into human trials and possibly animal trials as well. And underlying all of these are other agents that are looking for efficacy, they're looking for cost, they're looking for compliance. So, all of the things that you need to do to make it a business and not just a scientific exploration. So, if you think about that entire pipeline, you've got language models, you've got scientific foundation models, you've got embodied agents, you've got compliance and cost and safety, for lack of a better word, agents, all coming together to solve for better drugs. And more of this is going to happen. Where is a platform that enables all of these agents to come together and collaborate? And that's the problem that we went after, because it's not siloed to one vendor, it's not siloed to one cloud, it's not siloed to one vertical. It's really, really heterogeneous in nature. And trying to bring all of those things together to solve for one big goal.
In data science, the right hardware is essential for performance. This episode of Super Data Science is sponsored by Dell Technologies and Intel. Dell's latest AI PCs and workstations powered by Intel Core Ultra processors feature dedicated AI acceleration on the chip. This delivers faster inferencing, smoother multitasking, and longer battery life, even with demanding local models. Your hardware won't hold you back, whether you're prototyping in PyTorch or pushing production workloads. See how Dell AI PCs with Intel Core Ultra fit your workflow at dell.com/shoppcs. That's dell.com/SHOPPCS. Dell and Intel, designed for how data scientists really work. And so you're specifically talking about agency there.
So I'm talking about the Internet of Agents and how that translates to agency, which is the open source manifestation of Internet of Agents.
Gotcha. And so when we say Internet of Agents, does that includes in the future these real world embodiments? Like it's just basically the Internet of Agents is like the interconnectivity of all of these non-human intelligences that will be going around helping us on our screens or off our screens.
Yes. So when we think about the Internet of Agents is the embodiment of probabilistic agentic software in all of these verticals that we just talked about. So whether it's social interaction, scientific discovery, B2B software, services, as well as physical embodiment in physical AI robotics. And it's not just the communication aspect of it, but it's also how do we discover capabilities? How do we identify them? How do we compose them into workflows or, in fact, self forming teams? And then how do we help them communicate with each other? And then finally, how do we even help evaluate them? Because they're all here to do something for us. They're not just here to talk and communicate and have fun. So, how do we evaluate them and make sure that they're going towards a common goal?
Right, I've got you. And so the Internet of Agents and then agency in particular provides an infrastructure layer for the AI era, allowing all of this collaboration between agents, on their own and between human agent collaboration.
Correct. And you can think about it in terms of you can deploy agency, again, as an open source manifestation of the Internet of Agents. You can deploy the components of agency within your organization to handle all the agents that are being developed inside your organization, or you can deploy it in such a way that agents from different vendors and different organizations can also come talk to each other, collaborate, and solve for something. So it's like there's a microcosm of it within an enterprise, but there's also a macro, which lives outside a singular enterprise.
Cool. So the agency framework, which is open source and which people will have a link to it in the show notes. Again, it's spelled AGNTCY. That time I did look down and read it off a page. I don't know why I was so confident the first time. Don't want to overdo my luck. So yeah, we'll have a link to that in the show notes. Open source. It sounds like I suspect you have an even bigger vision for what agency will be in the future, but already today, it sounds like it blends together a lot of different kinds of functionality that different people have provided. Like, MCP provides tool use for agents, and then A2A is a framework from Google that is allowing inter-agent collaboration. It sounds like with agency, you're trying to provide an open source framework that allows all of these things together.
That's right. And I think so. If you think about how we took agency and moved it to the Linux Foundation, the formative members for the agency project in the Linux Foundation are, of course, Cisco, but there's Dell, there's Google, there's Red Hat, and there's Oracle. Those are the formative members. And then there are about 80 other organizations, both small and large, that are contributing, using, and deploying this at scale. So that's roughly where things are with agency. But also, like you said, so we, on the protocol side, we do collaborate with A2A as well as MCP. And we are a foundational member of the A2A project, that Google brought to the LF. So if you think about A2A, we are a foundational member, and Google is a foundational member of agency because we believe that fragmentation at this stage is a really bad thing. As it is, people are having trouble deploying agents, building agents, getting some traction and outcomes out, especially in the enterprise. And if you confuse everyone with multiple standards, multiple open source projects, we're not doing justice as technologists. So we all came together and made sure that when we say it's open and interoperable, we are truly being interoperable. And so if you think about the agency architecture, we actually show MCP as a protocol going from agents down to tool use and to data sources. And we show A2A as a protocol that sits between agents. Now, we are Cisco, we are a networking company, we've done this a while, and we all know that protocols are protocols and there'll be many, many protocols. And so the way we think about agency is we love all protocols. We love MCP today and A2A today. There might be 5 others that might prop up. If you think about the internet, you have IP, you have TCP, you have UDP. Even they were not sufficient, so the industry came up with Quick. So there are many, many protocols that come along. I mean, there's HTTPS that sits above all of this. So there'll be many protocols, and I believe that we are at the cusp of redefining that protocol stack that exists, and we can dive in that direction if it makes sense.
Yeah, let's do that a little bit. Because so terms like TCP, IP, for us data science listeners, we might not be familiar with that. HTTP, we have some idea because we see that in the web address. So, you have some idea that it has to do with the way that web pages are sent over the web securely. But TCP IP, I mean, having somebody from Cisco, you can probably explain that better than most people. And critically, you have a PhD in computer science from UC Davis that you got in the 90s. And so you have compared previously, you've compared today's agent ecosystem to the pre TCP IP days of the internet. So I'd love to hear, first of all, TCP IP, I know it's really important for the way that the internet works, but I wouldn't be able to explain it. So I'd love it if you can explain it and then explain how the moment that we're in today is analogous for agents.
So think about the early 90s. I mean, this was, again, when I was a bright eyed undergraduate. The internet was just coming out. This was 1995. And we had dial up. And I don't know if listeners here would remember it or even have experienced it.
I'm sure we will, because I did.
And so if you remember that dial tone where you would connect the computer to the internet through AOL, and AOL would come on a CD, you would pop it in, or maybe even a floppy, and you would pop it in, and it would dial into a phone line somewhere, and you would get 56, and I'm going to mess this up, you'll get 56 kilobaud or something like that. I don't even remember what it used to be. Really slow, let's put it that way. Really, really slow internet connectivity from a single provider, AOL. And so you had these islands of connectivity, and these islands never talked to each other. You had DECnet and Apple Talk and IBM SNA and a whole bunch of these other protocols and islands. And these networks actually did not talk to each other. It might seem surprising, but I'm on a Mac right now, and I should be able to just talk to Macs if Apple Talk was the de facto king. And if you're on a Windows machine, tough luck. If you're on a phone, tough luck. And so TCP/IP came in because Windsurf, in one of these meetings, stood up and said, "Enough is enough." You have BSD TCP/IP stack that was embedded in the BSD operating system from Berkeley, which was open sourced. And he came in and said, "We are all going to standardize behind the TCP/IP stack." And one of those books actually sits on my bookshelf over there, but that was a seminal moment in networking and Cisco was a big supporter of that. And what that did was it allowed packets from one box to flow to another box without it being siloed through a business need or a business requirement. So you truly opened it up, you truly made the network interoperable. And that's how the internet was formed because everybody signed up behind TCP/IP. We are at a similar juncture for agentic communication where, yes, some of us are talking to each other, but some of us aren't. And like I said, we did not stop at TCP/IP because it was invented in the 90s, I think late 80s, early 90s. The world has evolved. And so the requirements of TCP/IP have changed over time. So the reason QUIC came about is we needed the same guarantees of communication that TCP provides. I need to ensure that you and I, when I say a word, does reach you and vice versa. So I need that guarantee. But then TCP is pretty heavy. And I need that word to be transmitted to you, especially for communications, very swiftly with low latency. Because the one thing people hate is delays when you see audio or video. And so something like QUIC came about to marry the best of both worlds between TCP and UDP. So it gave the guarantees of delivery, but it also provided low latency interactive communication. Similarly, what we are seeing on the agent side is yes, we have MCP, yes, we have A2A, but there are many, many needs for agent to agent communication. And over time, we will see many protocols pop up. And as we create those protocols for a variety of needs, we need to make sure that there is a scaffold that exists around them, the scaffolding of discovery of agents. This is like the DNS. You said data scientists only know the URL. So, how does a URL translate to an IP address, which you don't really care about, but it does translate to an IP address? How does that happen? That happens through DNS. And so, what is the DNS system for agents? How do we do agent discovery and capability discovery? That's a scaffold around TCP/IP. That's a scaffold around A2A and MCP. So, the discovery, the identity, of course, the messaging layer that we just talked about, and the evaluation pieces that I mentioned earlier, this is the scaffold that needs to exist, regardless of the number of protocols that we all as an industry come up with.
Cool. I understand all of that now, and I understand the analogy. It makes a lot of sense to me. Something that I understand is a big issue for agents today in this, this early ecosystem, this early internet of agents where we don't have all of the protocols sorted out. One of the issues that I understand we run into is identity and access management. So AIM is the abbreviation used for that often, which is kind of a fun thing because it's like I am and you're providing your identity, you're saying who you are. So I am, that's a clever thing. I'd never noticed that before. And so traditional IM, internet or identity and access management systems often break down when applied to AI agents. Why is that?
So identity and access management, by the way, I didn't even think of it as I am, which is a great analogy there. But the reason the breakdown is so far all IAM services and systems have worked with humans or deterministic software. And agents are a combination of the two. So agents are like humans in the way they communicate, in the way that they are using NLP, but also in the way that they act and behave and change their persona. So they're all probabilistic in nature. You cannot predict. I mean, you ask ChatGPT the same question 5 times over, you'll get 5 different answers. And so they're very, very probabilistic in nature in terms of both intent and in terms of outcome. And they also operate at machine speeds and scale. So unlike Vijoy, who of course is hallucinating half the time, who's unpredictable, and is actually speaking natural language, but thankfully Vijoy is not running at machine speed and scale. So if you give Vijoy sub-access control to do some damage, you only give that access control for a short period of time. So you can think hours, let's say, or even days. Great. But agents are acting on behalf of Vijoy today, might act on the behalf of John in the next minute, and they're doing this at machine speed and scale. And how do you build an identity and access management system to handle this probabilistic behavior at scale? And that is the big problem. So typically the positions that we've used in IAM are three kinds of positions: role-based access control, attribute-based access control, and relationship-based access control. These are the things that we've used in IAM to identify what access to give a human or a piece of software. And role-based access control works, again, because humans have certain roles and they don't deviate from those roles in a certain context, like within an organization. Agents, like we just discussed, are not in the same time-boxed, role-boxed environment, and so they will differ, and we need to treat them differently.
Are you tired of spending weeks building dashboards that your stakeholders never use? Well, suffer no more, because Fabi.ai was built to solve this. Instead of hoping your business partners will check another dashboard, Fabi lets you meet them where they already are. With Fabi, you can automate the delivery of insights directly into your stakeholders' workflows, including Slack, email, and spreadsheets. This makes a big impact. One Fabi client eliminated 30 hours per week of manual data work by automating their alerts to Slack, while another reduced self-service requests to their data team by 90%. Now that's nice. Visit Fabi.ai today to see how AI-native analytics can transform your data team's impact for free. That's Fabi.ai. All right, so, okay, now I understand why IAM systems break down for AI agents, and it totally makes sense to me there that a big part of the issue is that it's the machine scale, it's the machine speed that you can, if you provide permission to agents, you can all of a sudden have so much activity happening, so much network activity, so much real world impact in a way that a single human never could. So it just kind of, it scales up the security risks associated with identity and access management. So yeah, what is the solution?
So identity and access management for agents needs to go back to basic first principles and think about what is it that we're truly trying to achieve by giving somebody access to a protected piece of software, protected data object, or whatever it is that you're trying to give access to. So the basic principles behind that is looking at the task that you're trying to achieve, the tool that you're trying to access, or the transaction that is taking place. So we defined this whole notion of TBAC. So T stands for task, tool, transaction based access control. So that's the T back. Sometimes we want to call it T3 back because there are three T's in this equation. But this is going back to first principles and saying, instead of trusting an agent by saying, this is an agent for Vijoy, so let me trust that this agent is going to behave like Vijoy for the next 5 days. Instead of doing that, I'm going to go back to first principles of zero trust and say, Vijoy's agent, what is it that you're really trying to achieve? Which task are you trying to do? And based on that task, I'll figure out what level of authorization and access you need. I'll give you a token to go and do that task at that level of authorization. And then I quickly bring you down before the next task or transaction or tool access takes place. So it's going really, really granular, figuring out what a task could be, elevating your privileges if needed for that task or tool access or transaction, and then quickly bringing you back, because it's not just the speed, like you said, John, but it's also the probabilistic nature of the agent, because it's not deterministic software. It's machine, it's software, and it's the data being fed into it and the probabilistic outcomes and the probabilistic communication that is taking place with the agent that makes it behave differently from 1 second to the other.
Right. I've gotcha. Yeah. The probabilistic nature of the machines makes it particularly, yeah, difficult to trust machines because even if even if you actually trust the person who's provided this capability, probabilistic things, the probabilistic nature of LLMs means that you could get unexpected outcomes anyway, which could lead to security issues. So you have this zero trust agency (ZTA) framework, and yeah, and you have these two different types of access control. There's TBAC, or as you said, T3 back, because it's task, tool, and transaction based access control. And then, so that is what you were just describing, where based on some specific task or some specific tool or just one particular transaction that you need an agent to be involved with TBAC, you're just providing control for that particular task, that particular tool, that particular transaction. And so that differs from the other way that you could be providing access control, which is role based. And it's that role based, ROLE, that role based access that is kind of, I guess that's traditionally what we were used to. You used to have, like, Vijoy would have access, or John would have access, or whoever would have access. That was role based control. But now in this agency world, it makes more sense to have this TBAC, which is much more specific.
Yes, and I think the way to think about this is you still will have role based access control for humans. You will still have attribute based access control and relationship based access control for software and humans and services that are deterministic in nature. But for agents, we want to move towards T3 back or TBAC, task tool transaction based access control. And we need to bridge these two worlds because the old world is not going away. John will have role based access control, Vijay will have access control, which is role based. But my agent and your agent, and sometimes it's the same piece of software that is taking one persona at some point in time and some other persona at some other point in time. And so we do need to bridge the R-back systems of the world to the T-back systems of the world for this multi-agent human societies to come together from the identity standpoint. I mean, if you're just looking at that narrow piece of the vision. And the other thing is, right now, everything that, I mean, there's a translation that's happening here, right? So I think you mentioned sometime in the past, but we all know this, where humans are going to be part of the loop for a long time to come. So even though there'll be agents in a workflow, in a self-forming team, whichever way you can think tasks will evolve or teams will evolve, humans will be part of the loop, or human in the loop is going to be a thing for a long time to come. And so that's the other reason why role-based and task tool transaction-based access control need to talk to each other, because there'll be points in this workflow where you will need to punt to a human and say, are we doing the right thing? Are the agents doing the right thing? Do you approve of this? And so that's the other reason why we need to bridge these two worlds together. But as far as agents are concerned, we have to move towards this first principle based access control, which is TBAC.
Nice. That makes a lot of sense. When we're working with something like TBAC, it sounds like it might be tricky. Like, I can't wrap my head around exactly how permissions are granted just in time when you need to grant permission to an agent to be able to do a particular task, and then you need to revoke that afterward. That sounds like it could be complicated. How do you handle it?
We have to bring in a whole bunch of infrastructure around this notion of TBAC to enable the end goal, which is the zero trust for agents, which is I give you permissions to do something specific for that just in time, and then for that duration of that task to or transaction, and then I revoke that token or revoke those permissions the moment you're done. So what else do you need? So in my head, the equation runs like this, which is zero trust agency is I don't trust any agent, and I just trust it once it's proven that it's supposed to do X, Y, or Z for the duration of that X, Y, or Z. and then I revoke those permissions. So that is zero trust for agents, is a combination of the availability of trust, a task tool, transaction-based access control. So all identity providers, authorization servers need to support TBAC. That's step one. We need to have a parsing entity for all communication that's taking place between agents and humans that can parse that communication, that parse that discourse, and figure out the tasks or the tool access or the transactions that are taking place between agents. So that's the second piece, because that'll help us define what those tasks, tool access, and transactions are. So there's a semantic parsing element. And then your just in time comment basically implies that you get a token, you do that task in a very contained sandbox, jailed environment, and then you're taken out the moment you're done. So the analogy I draw here is I want to access a safe which has a lot of money, but I want to withdraw $10 from the safe. Now you can give me, since I'm Vijoy, you can give me access as Vijoy to go and open that safe. And that's role based. But then you can say, you know what, there are other people's money in that safe. So I'm going to give Vijoy just enough to withdraw cash for the next 10 seconds and then move out. So that's like a task-based access control. But then I need to parse the communication that's happening between myself and somebody else, where we are talking about withdrawing $10, and say, okay, Vijay is allowed only to withdraw $10, and that is the task he's doing. So let me just give you access for that $10 withdrawal and not sit around to withdraw all of the money from the safe. So that's the task-based parsing that needs to happen. And finally, I'll let you into the sandbox environment, give you that authorization to withdraw $10, and then I'm going to shut the door. Because I don't trust you beyond that point. I will not let you linger around that safe. So that is a sandbox runtime environment that needs to happen. So is the hooks in identity providers to provide task-based access control, is a semantic parsing of the discourse of the communication to figure out what that task is, and then a runtime sandbox environment to just do that task with that authority and then get out. So those are the three things that need to come together for zero trust for agents to happen.
Semantic parsing, ephemeral runtimes, and human in the loop approvals. And overall, you gave me a really clear picture now of what this all involves. One thing that I guess I still don't quite get logistically. You said that you won't trust the agent even for, the particular task, tool, or single transaction that you're going to approve it for until the agent has proven itself. How do agents prove themselves trustworthy in the first place?
This is where the entire pipeline comes to the picture. So we are looking at identity, which is the first stumbling block that everybody is running into. And so one of the things that we're seeing is in the agency framework, the identity piece is the problem to solve first, even before you can start deploying agents at scale within the enterprise. But then, like as you pointed out, there are other aspects of trust. There are other aspects of semantic parsing. So there are these other aspects of that entire pipeline that we need to solve for. So coming back to trust, the simplest way you can start with is saying, is there a directory somewhere that allows me to discover agents that are trusted? So I want to find a financial agent, not from a particular vendor, maybe, but also if there are 10 vendors, I want the best of breed financial agent from a vendor that is highly reputable and highly trusted. So the simplest version of your answer of the question, the answer to your question is there a directory which tells me which agents are trusted agents? But then the next question is, so that's where the directory comes in. So we have a directory where you can discover agents through capabilities and through things like reputation and trust. But then the next question would be, how is that trust enforced or attributed? Is it crowdsourced? Crowdsourced could be one thing. So 10 people have used it. It's like the Apple App Store, which says 5 stars, trust, or a trust pilot score. And it's like, yes, it's awesome. But if you want to be a little bit more mathematical and provide some rigor, then you go to the last pillar of that 4 pillar thing that I talked about earlier: discovery, identity, communication, and evaluation. You look towards evaluations, and you look towards evaluating agents and multi agent workflows and saying, over time, I've built trust by evaluating this agent. And that trust can then feed back into the directory's reputation score and say, yep, all good to go. Till something perturbs in the system, because these things are constantly evolving.
That's cool. I get it. So this is kind of like when I'm on Amazon and, there's some product that I want to buy and one vendor on Amazon is providing the product for $5 cheaper than another, but the one that's doing it for $5 cheaper has a 70% approval rating from people who have made purchases before, and the other one has 100%. I'm going to pay an extra $5.
Right. And in that example, you and I who are buying this product are the evaluators. And Amazon is the discovery directory engine, which has the trust reputation score attached to it. Because we as evaluators are actually feeding back into Amazon and saying, this thing sucked, so bring it down even further, or this is awesome.
Gen AI and classic machine learning are great at solving a lot of problems, but they are not built for complex decision problems. Even a slew of agents can't deal with all the possibilities when there are trillions or trillions of possibilities. Mathematical optimization, in contrast, is the perfect complement to these skills for decision making at scale. To get you going, Gurobi has hands-on online trainings made just for data scientists. The latest installment of optimization for data scientists, called Opti 301, is just around the corner. To catch up on this series, register for the upcoming training, and to check out other resources like case studies optimization, head to gurobi.com/learn. That's GUROBI.com/learn. So does all of this that you've now covered in the episode, so things like the Zero Trust Agency framework, things like TBAC, does that allow me as a data scientist or as an AI engineer now to maybe be able to get more of my agentic projects approved by enterprise security teams?
True, and that is the whole goal behind this, right? So when we thought about the Internet of Agents and agency in the open source, the notion behind the entire project was to ensure that agentic workflows and self-forming agentic teams and getting agents to do business outcomes or perform business outcomes, the bar to that is lowered or becomes easier. And that's where we started. So identity is a big stumbling block and a problem to solve. Evaluation is a problem to solve. If you think about an enterprise like Cisco, we are dealing with agents from a Salesforce or from Cisco, Microsoft, ServiceNow. All of these things need to come together to build a simple sales funnel, for example. And so these agents are all sitting in their own clouds, different vendors, different clouds, different intent and outcomes. So if somebody says, give me the best X, what does best mean? When some agent comes back and says, here's the best X with 90% confidence, is it 90% well understood across all agents, or is it a vendor by vendor thing? And so looking at discovery, identity, bring them together and helping them collaborate and evaluating them, these are the 4 steps of the pipeline that we saw enterprises struggle with on a day-to-day basis. So to your question, yes, data scientists, I'm an engineer, we are all focused in on the outcomes that we want to deliver on our product, on the thing that we're working on. But if you take a step back and to your point, think about adoption. There are these really hard brownfield heterogeneity problems that we need to solve. And agency is out there to solve for it in an open source, open interoperable way.
I like it because for me, I like to be able to focus on capabilities and I don't want to have to worry too much about security myself. And so I'm glad when folks like you and agency come along and you solve my security problems for me in a kind of and a key, like, yeah, you just solve all the problems for me and I don't have to handle them. It's great. Turnkey is the term I was looking for there.
Yeah, so it is an open source project. And one of the ways open source gets adopted and grows and is successful is if it is not a biased viewpoint. And so the way we think about agency and open source in particular is we want practitioners, we want developers, we want vendors, we want operators, we want consumers and customers, all personas and roles to come in, play with agency, figure out what's working, what's not, whether it's helping, whether it's not, is the documentation up to snuff, any which way possible, help us grow that community, help us utilize the projects, provide real feedback. So even though you would expect, and we want to provide a turnkey solution through the product stream that Cisco is building, based on agency, the open core part of agency, the open source part of agency, could benefit a lot from developers like you, practitioners like you, and the listeners here to come in and just contribute in whichever way that you deem necessary.
Nice. And so if people want to get started today with agency, they like the sound of what you've been describing, they want to be able to have a more interoperable system for their agents to work with each other, to work with humans, and for this to work in a way that happens across whatever kind of framework they're using. It works with Crew AI, it works with LangGraph, Llama Index, whatever. So, obviously we're going to have the GitHub repo in the show notes for people to go to. Is there anything they should know? I'm seeing, for example, that there's something called Coffee Agency, which is a fictitious coffee company that helps developers, scientists understand how components in the agency ecosystem can work together. Maybe is that a place that you recommend people starting, or yeah, where should people get started with agency if they're curious?
You can absolutely go to agency.org, and I'll spell it out again this time. So it's AGNTCY.org, and that's where you will get access to documentation. You'll get a pointer to the Git repo, and you can join and have fun. But like you pointed out, Coffee Agency is an open source reference application that we built, and it's truly a coffee agency. So we've got multiple coffee suppliers. It's a supply chain problem that we show. There are coffee manufacturers scattered across the globe. There's a full supply chain, and then there's a coffee shop that is trying to actually sell coffee. And we picked this because A, we love coffee, and B, this is a pretty complicated supply chain example, which brings in all of the complexity that any enterprise goes through. And it's a reference application because it's a real application, but the entire code is open sourced. So you can plug and play various components within the application. So it's not just the agency components within Coffee Agency. Of course, it has A2A, it has MCP, but you can plug in Cassandra and see how that works. You can plug in, TIBCO as a messaging bus and see whether TIBCO will work as an inter-agent collaboration platform. So or you can plug in various IDPs like an Okta or a Duo. And so this is one place where you can bring in your environment into this reference application and then swap things in and out. Maybe it's your code, maybe it's somebody else's code, and see the benefits of using these various components and build out a real world example before deploying it into production in your environment.
Nice. Very cool. Thank you for doing this for us. Why are you doing this for us? Why does Cisco invest, and all these other vendors, you mentioned tons that are involved in this agency project. Why, what's in it for Cisco in the end?
Few things. First of all, we truly believe in the open, interoperable future of multi-agent human societies. I mean, at least that's my belief. And Cisco is a big proponent of an open, interoperable internet and has always been. But that's a vision statement, that's a belief statement. There are business ramifications to it as well. And the business ramifications come again from the belief that open systems provide the maximal value for every participant in the ecosystem. So whether you are a vendor like us, whether you are an operator, whether you're a developer, whether you're a customer or a consumer, every persona in that ecosystem benefits if that ecosystem is open. From the dollar perspective, customers will get cheaper, interoperable products. Vendors will make more money because this thing is widely adopted. So if you think about the value prop for every business, they will get maximal value if the ecosystem is open and interoperable. So that's the reason why we're in it. And also we feel that building this internet of agents is pretty much our birthright. And participating in this is something that we do well because we understand distributed systems, distributed computing at scale. And the next step towards distributed computing is actually agentic distributed computing. And so we want to go after that future, and we can build it in the right way.
I love that. Makes a lot of sense. Cisco are the masters of the internet. Why not be the masters of the internet of agents that it's coming? Makes a lot of sense. Before I let you go, actually, I was about to start getting into the final questions that I ask all my guests, but right before that, one final one popped into my head. Vijoy, what's next for this initiative? What's next for Agency?
Agency so far, I mean, we touched upon this a little bit in the earlier conversations, where we are building the scaffold for these different agents sitting in different organizations with different roles and personas on different clouds from different vendors to all come together to solve for a business or a consumer or scientific or physical work outcome. The problem is that right now, whatever exists out there in agency and in other protocol layers and other frameworks like A2A and MCP and other frameworks that you mentioned, we are dealing with this heterogeneity, this complexity, this interagent collaboration at a certain layer. So we are dealing with what I call the syntactic layer of complexity. So this is like saying agent one and agent two, you and I speak German, you speak Japanese. We are trying to figure out the structure of our language. And we just want to standardize on English. So we say, okay, noun before verb or verb before noun. This is how a sentence is constructed. And that translates to a framework. So whether you're built on a line chain or line graph, or whether you're built on a Crew AI, or whether you're built on a Bedrock or the Agent SDK from Google, these are frameworks and these are just syntactical representations, and you need to make these things interoperate. But there's a bigger problem at hand. And the bigger problem, especially if we are true to our vision, which we are, we believe in this vision of multi agent human societies. The bigger problem is to understand each other semantically. So even if though we are speaking English, are we standardized on what we mean when we say certain things? So when we say best, when we say 90%, when we use a certain terminology or a phrase, are we standardized on that? And can we understand the meaning behind the communication that's happening? So the semantic layer is actually the next set of problems to go after. And when you go after the semantic layer, that's why I said there are many, many more protocols that will appear. But it's not just the communication part. The moment you start getting with the semantic layer, you're dealing with knowledge, you're dealing with cognition. As the problems get really, really interesting, when you take knowledge and cognition and you start spreading that around, and you start thinking of it in terms of societies. So that's what's next when it comes to Internet of Agents, per se.
Nice. Getting closer and closer to that vision that you mapped out at the beginning, where agents and humans are working together to solve the biggest problems facing society and making the world a better place to live in. I certainly share that techno-optimistic vision. Some people might think we're too optimistic, Vijoy, but I don't know. You can't stop the tech. It's going to keep coming. And, there are certainly downsides to technology, but by and large, if I had to pick a time to be living in history, I want to be born now, not 100 years ago or any
And
time before that.
as a technologist, John, yes, every piece of technology has a downside or a negative aspect. But as technologists, I believe that we should build technology to solve for the problems that technology creates. So we need to solve it through fundamental principles and make things better. And that's just good business.
For sure. All right, Vijoy. So I already kind of alluded that this was going to happen. I snuck one last question in there. Uh, every guest, I ask them before I let them leave the show for a book recommendation. What do you have for us?
My favorite book is The Life of Pi.
Oh, yeah, Life of Pi. Cool.
And there is a big reason for that because I believe we live in a very probabilistic world. I believe that just like quantum physics, and that's the other thing that we dabble in, day out, within Outshift, we're looking at the quantum internet and quantum networking. I believe that there is a superposition of states, and we are just measuring and looking at one state, and that's what we are in right now. And so you can believe in either science or you can believe in faith or a combination thereof. It's up to you, it's up to all of us. But whichever way you're leaning, there is a story that you believe in. There's a scientific story that you believe in, there's a story around faith you believe in, or somewhere in between. That's a story. And The Life of Pi, to me, was the eye opener in the sense that we all believe in stories. It's also like Sapiens. We are a big believer in stories. But The Life of Pi told me that believe in the story, which is more fantastical, which drives more excitement, and which will make you live a more interesting life. Because you can always decide to believe in the boring story, which is what fun is there in that? So if you're going to believe in some story, believe in one that is going to drive excitement for you and just stick to it.
That was a cool book pitch. I loved Sapiens, and it sounds like I'm going to now have to check out Life of Pi. So, we're blending deterministic and probabilistic models to get the best outcomes for our enterprises. We can blend science and faith to get the most interesting outcomes for us as individuals. Cool. And yeah, very last thing, Vijoy, is how should people follow you for your brilliant thoughts after this episode? Obviously, we know to go to the agency website and the agency GitHub repo, which I'll have in the show notes. But what about you personally? Or are there any other links, from Outshift or something that our listeners should be following?
So I think agency.org was for agency. You can go to outshift.com. That's to follow everything that we're doing in Internet of Agents, but also the quantum internet side of the house, which is even more fascinating and mind-blowing. But to follow me personally, of course, I'm on LinkedIn. I'm the most prolific on LinkedIn. So you can follow me on LinkedIn, which is /in/Vijoy, on Twitter and X. And then I have a website, which is a little bit dated, but I'm trying to update that. But I think LinkedIn is the best place to follow.
Nice. Thanks, Vijoy. I agree that LinkedIn is the place where you can probably find most of our listeners and most of our guests these days. It's pretty interesting how that's happened. Great to have you on the show. I really enjoyed this episode. You are brilliant and fun to speak to. Thank you so much for taking the time out of what is surely a very busy day for you.
This was a fascinating conversation. Thank you, John.
In today's episode, Dr. Vijoy Pandey covered his vision for multi-agent human societies where agents and humans collaborate to solve everything from scientific discovery to physical tasks, freeing humans to focus on creative work. He talked about AGNTCY, Cisco's open source platform for the Internet of Agents that enables agents from different vendors and clouds to interoperate and collaborate. He talked about the importance of blending deterministic and probabilistic tools rather than abandoning proven deterministic approaches for pure AI solutions. How digital twins of humans, systems, and the physical world are key to building reliable agentic systems that can be tested safely before deployment, and the evolution from syntactic interoperability between agents to the harder problem of semantic understanding, where agents, quote unquote, comprehend the meaning behind their communications. As always, you can get the show notes, including the transcript for this episode, the video recording, any materials mentioned on the show, the URLs for Vijoy's social media profiles, as well as my own at superdatascience.com/941. Thanks, everyone on the Super Data Science podcast team, our podcast manager, Sonia Brevich, media editor, Mario Pombo, partnerships manager, Natalie Jaisky, researcher, Serge Massis, writer, Dr. Zara Karshay, and our founder, Kirill Eramenko. Thanks to all of them for producing another exceptional episode for us today, for enabling that super team to create this free podcast for you. We're so grateful to our sponsors. And if you are ever interested in sponsoring the show, you can find out how to do that at johnkrohn.com/podcast. Otherwise, share, review, subscribe, but most importantly, just keep on tuning in. I'm so grateful to have you listening, and I hope I can continue to make episodes you love for years and years to come. Until next time, keep on rocking it out there, and I'm looking forward to enjoying another round of the Super Data Science podcast with you very soon.